Acanthomyces aculeates. The moth Acanthomyces. Thin, rod-like structure with an expanded to club-like apex, 1 to 8 millimeters long and 0.1 to 0.5 millimeters wide. White, partially arising from white mycelium that completely covers or partially covers the body of a dead moth and usually extends to the substrate upon which the moth occurs. Spores, hyaline in mass, 3 to 6 by 2 to 3 micrometers, broadly elliptical or egg-shaped, smooth. Habitat, biological role, parasitizing and emerging from the bodies of moths with multiple rod-like structures arising from a single moth, usually appearing during the summer but can linger into winter. Parasite of insects, in this case, moths. Distribution. Frequent in our region during wet years and widely distributed throughout eastern North America and elsewhere in the world, most frequently in the tropics. Comments. The host is often attached to a branch or leaf above the ground. Cordyceps tuberculata also occurs on adult moths, but differs in having several stalks with several prominent yellow to pale brown paratheci near apices. The anamorphic stage of C. sphingum is similar, but the conidia are solitary, whereas the conidia in Acanthomyces aculeates are chain-like. Other Acanthomyces species found in our region are not reported to parasitize adult moths. The distinctive A. aranarium parasitizes spiders. It has multiple thin, club-like stroma arising from the host with white upper portion when young and is pale brown with age or at base. Edibility is unknown, but if dried with care, specimens keep well and are great for conversation pieces or teaching tools. In our region, a very common parasite of the Carolina leaf roller cricket looks very similar, but currently seems to be an undescribed species of fungus. Beauveria bassinia, pathogenic insect mold. Layer of white mycelium that covers portions of the body of a dead insect or other arthropod, e.g. spider, powdery due to the presence of masses of spores, frequently fruiting at the exoskeletal joints. Spores, white in mass, 2 to 3 by 3 micrometers, more or less globois, smooth. Habitat, biological role, colonizing the bodies of insects, both adults and larvae. Parasitized insects are most commonly encountered in summer, but can be found throughout the entire year. Parasite of insects and other arthropods. Distribution. Found throughout the world in soils, but evident macroscopically only when colonizing the body of an insect or other arthropod. Comments. This exceedingly common fungus can infect a broad range of insects and other arthropods. In the southeast, we have observed it occasionally parasitizing spiders, but primarily on a wide diversity of insect hosts, including beetles, coleoptera, cicadas and tree hoppers, hemiptera, ants, bumblebees, and hornets, hymenoptera, praying mantis, Mantodia, and grasshoppers, Orthoptera. When the spores of this fungus come into contact with a suitable host, they germinate, penetrate the body, and kill the host within a few days. Afterward, the masses of spores, which have a cottony appearance, emerge from the joints in the exoskeleton. This is a similar fungus in our region that parasitizes crane flies, Diptera. The fruitings of this species are common around the edges of swampy riparian areas, and the flies are usually attached to moist rocks and logs by a translucent white mold. The edibility of these fungi is not known, but moldy insects do not typically top the list of gourmet items. There is a potential application for them as insecticides. Cordyceps militaris, the orange club. Cylindrical to club-shaped structure with a clearly distinct head and stalk. Total height 2 to 5 centimeters. Bright orange to orange-red or pale orange. Head 1 to 2 centimeters long and up to 5 millimeters wide. Surface roughened with numerous raised dots. Stalk 0.5 to 3 centimeters long, tapering slightly downward, reddish-orange, emerging from moth pupae. Spores colorless in mass, 2 to 4.5 by 1 to 1.5 micrometers, segmented and breaking apart in elliptical fragments. Occurring habitat biological role. Occurring on the ground among dead leaves or sometimes emerging from well-decomposed wood, appearing in early summer to fall. Parasite of moth pupae. Distribution. Found throughout North America, but most common east of the Rocky Mountains. Comments. The fruiting bodies of Cordyceps militaris appear to be arising directly from the ground or decomposing wood, but careful examination of the base of an individual fruiting body will reveal its attachment to the pupa of a moth. Occasionally, several fruiting bodies are observed to rise from a single pupa. Cordyceps militaris has been shown to have many beneficial medicinal properties similar to those of the valuable Asian Ophiocordyceps sinensis. Cordyceps cardinalis is nearly identical to C. militaris, but is a parasite on the larval stage of moths and has genetic as well as subtle microscopic differences. Trichoderma alateosium is very similar in appearance but grows on wood, not insects, and has a more yellowish to pale brown fertile portion and whitish stalk. Cordyceps tuberculata. Parathecial moth cordyceps. Cylindrical structures arising from the white mycelium that partially or completely covers the body of a dead moth. 1 to 11 millimeters long and 1.5 to 2 millimeters wide, usually narrowing somewhat toward the apex, the latter with a cluster or row of tiny, flask-shaped to pimple-like projections present. These yellow to yellowish-brown spores, hyaline in mass, initially thread-like and with multiple cross walls but breaking up into smaller portions, termed part spores. These 2 to 6 by 0.5 to 1 micrometers, smooth. Habitat biological role. Parasitizing and emerging from the bodies of dead moths, with multiple cylindrical structures arising from a single host, usually observed during the summer. Parasite of moths. Distribution. Most common in the southeast during wet years and widely distributed throughout eastern North America and elsewhere in the world, most frequently in the tropics. Comments. Acanthamyces aculates is similar, but the structures arising from the body of the dead moth are not as robust, and there are no flask-like, pimple-like projections at the apex. Neither the edibility nor the medicinal properties of Cordyceps tuberculata are known. However, many Cordyceps species have been shown to have the latter. Isaria farinosa. Powdery Isaria. Tree-like or club-like structure, variable in size, 0.5 to 6 centimeters tall and 0.2 to 2 centimeters wide, sometimes with multiple stalks arising from one host, upper portion forked and densely branched or sometimes consisting of just a solitary club. White to pale grayish, powdery, usually releasing white spores in a cloud if brushed or moved suddenly. Stalk smooth, equal to irregular, very variable in length, sometimes nearly absent or making up the majority of the length of the entire fruiting body. If present, usually 1 to 5 millimeters wide. Stalk very variable in color, ranging from white to pale grayish or cream to lemon yellow, rarely bright orange. Stalk attached to the body of a dead insect host. Spores, conidia, white to hyaline mask. 1 to 2.5 by 1 to 1.5 micrometers. Oval to subglobose, smooth. Habitat biological role. Usually emerging from the soil, leaf litter, or decomposing wood where the hosts are located, appearing from summer to fall. Sometimes in winter. Primarily a parasite of moth pupae, or rarely moth caterpillars, but reported occasionally from other insects. Distribution. Most common in the southeast and east, but widely distributed in North America. Comments. Despite extensive research, The teleomorphic, sexual stage of this fungus has not yet been determined. However, it is likely to be something related to the genus Cordyceps. The taxonomic history of Isaria farinosa is complex, and when the diversity of morphological characters and host species are considered, it is certainly possible that I. farinosa is a species complex. However, some mycologists report that there is, based on molecular evidence, primarily one species in our region. We have collected specimens in the southeast that are very similar morphologically to I. japonica, but it is unclear if the southeast is within the range of this fungus. Isaria species are not eaten, but some contain interesting medicinal compounds, and many have shown potential as insecticides. Ophiocordyceps melilanthae, beetle cordyceps, rhinoceros beetle cordyceps. Stalk-like structure, 5 to 8 centimeters long and 3 to 10 millimeters wide. Equaled, smooth, sometimes forking, base attached to a soft-bodied beetle, larva. Pale whitish yellow to bright yellow, with maturation enlarging irregularly toward apex, developing parentheses, apex sometimes remaining sterile, parentheses giving the surface a punctuate appearance, similar to or darker than the stalk in color. Spores hyaline in mass, forming filament-like chains and breaking apart into shorter partial spores, 4 to 10 by 1 to 1.5 micrometers, smooth. Emerging from the soil and leaf litter where the host beetle larvae are found, fruiting summer to fall, parasite of beetle, Coleoptera, larvae. Distribution, found throughout eastern North America. Comments. This is one of the largest species of insect pathogens likely to be encountered in our region, and one of the few associated with soft-bodied beetle larvae. Cordyceps cardinalis and C. militaris are the most morphologically similar species. However, they are generally smaller, orange in color, and associated with moth pupae or larvae. To our knowledge, Ophiocordyceps melilanthae has not been evaluated for edibility or tested for medicinal properties. Ophiocordyceps variabilis, the fly larva cordyceps. Slender stalk-like structure, 5 to 17 millimeters long and 0.5 to 1 millimeters wide. Straight to curved or sometimes forking. Surface smooth to finely powdered. Base of stalk attached to segmented fly larvae. Stalk yellowish-orange to reddish-orange. Fertile portion irregular in shape, consisting of clusters of parentheses, sometimes as few as 10 parentheses in a cluster. Clusters variable in shape and sometimes forming a cushion-like structure that wraps halfway around stalk midway up, and at other times forming capitate head at the apex of the stalk. Fertile portion similar to the stalk in color or sometimes darker. Spores hyaline in mass, forming filament-like chains and breaking into shorter partial spores, 5 to 10 by 1.5 to 2 micrometers. Smooth. Habitat biological role. Emerging from decomposing logs where the host fly larvae occur. Sometimes several fruiting bodies can be found on one log, appearing from summer to late fall. Parasite of the larvae of flies, Diptera, particularly members of the family Xylophagidae. Distribution. Most common in the southeast and east, but found throughout North America and South to Central America. Comments. This small fungus can be distinguished from other members of the genus Ophiocordyceps and Cordyceps on the basis of its small size, type of host, and the variable shape of its fertile structures. Cordyceps cardinalis and C. militaris are somewhat similar in color, but these two species are generally much larger, have embedded parentheses, and are associated with moth pupae, or larvae that only rarely occur in logs. The reddish color and obvious exoskeletal segments of O. variabilis host frequently cause it to be misidentified as a beetle larvae. This fungus is too small to be of culinary value, and we do not know of any tests of its medicinal properties. Its asexual stage is Syngiocladium tetanopsis. Turibula arachnophiliae ver Leopis. Spider cordyceps. Thin, rod-like structures, tapering from the base toward the apex, length varying and related to the size of the host. 0.5 to 7 millimeters long and 0.1 to 5 millimeters wide. White to yellowish to pale pinkish, arising from a white mycelium that partially or completely covers the body of a dead spider and usually extends to the substrate upon which the spider occurs. Spores, hyaline in mass, 2.5 to 6 by 1.5 to 2.5 micrometers. Fusoid elliptical, smooth. Acospores, 450 to 650 by 1.5 to 2 micrometers. Thread-like, breaking into segments, 4 to 10 micrometers long. Habitat, biological role, parasitizing and forming fruiting bodies that arise from the bodies of spiders. The latter generally attach to the underside of leaves, fruiting during moist summer weather. Parasite of spiders. Distribution, widely distributed throughout eastern North America and elsewhere in the world, most frequently in the tropics. Comments. The asexual, anamorphic stage of this fungus, Gibellula leopis, pictured, is more common than the sexual, teleomorphic stage. Turibula arachnophilia ver pulchra is most easily differentiated by its anamorph, G. pulchra. Gibellula pulchra occurs in our region, but is less frequently encountered. It is very distinctive in having minute, less than 1 millimeter long, structures with small heads at the apex that cover the erect stalks, which are attached to the body of the spider. Acanthomiaces aranum is similar in that it parasitizes spiders. However, the parasitized host is usually not attached to the underside of a leaf, and the lower portion of the fruiting body is typically orangish-brown. All these fungi are too small to be of culinary interest. Some related species have shown interesting potential medicinal properties. However, to our knowledge, none of these species have been tested. We'll move on to morels and relatives. Because of their culinary value, morels are among the best-known groups of fungi. In some parts of western North America, people make their living as migratory morel pickers, following where the previous year's fires have been. They also often start in the mountains of California and follow the season north, all the way through Canada and into Alaska. Most of the morels picked commercially in these burned sites are blackish to brownish in color. They are not the species we have in the southeast. In eastern North America, we find some black to brown morels, but the yellowish or blonde morels tend to be more common. The eastern species of morels do not seem to be fire-affiliated and are usually found among the early spring wildflowers, making it challenging to spot their well-camouflaged fruiting bodies. The true morels, Morchella, are variable in color but always have a head-like structure with distinct pits and ridges at the apex of a hollow stalk. Morels are some of the best-tasting and most easily identified edible mushrooms. However, they should never be consumed raw or with alcohol, and there are a handful of reports of a rare food allergy leading to mild gastrointestinal issues for some people who consume a member of this genus. Some of the poisonous false morels can resemble the genus Morchella. However, a careful study of the following descriptions should alleviate any concerns of misidentification. The ecology of these groups is not yet well understood. Eastern morels have different folk names, particularly within the Appalachian Mountains. The common names we have frequently encountered are molly moochers, dry landfish, haystacks, muggies, sponge mushroom, honeycomb mushroom, and snakehead mushroom. Whatever you call them, it is always an enjoyable challenge to go out into the spring woods and hunt for these elusive and tasty mushrooms. Gyromitra corfi, the bullnose false morel. Contorted to a brain-like structure, stalked, the upper portion cap-like, 2 to 12 centimeters wide, and folded downward, irregularly folded, sometimes divided into folded lobes. Upper surface smooth, with irregular wrinkles, the margin usually curving up away from stalk or sometimes fused with it. Pale to dark brown or sometimes dull yellowish brown. Lower surface finely granular, dingy whitish pale or pale grayish. Stalk 1 to 7 centimeters long and 2 to 7 centimeters wide, equal to enlarged towards the base, sometimes covered by dirt. Usually ribbed, white to grayish, stalk interior stuffed with cottony white hyphae, spores hyaline in mass, 24 to 36 by 10 to 15 micrometers, elliptical to spindle-shaped, smooth to finely reticulate, and in mature processes, spores sometimes having blunt terminal projections. Habitat, biological role. Occurring as solitary fruiting bodies or in small groups on soil in broadleaf or mixed broadleaf conifer forests, fruiting from early springs to early summer. The ecology of this fungus is not yet fully understood. It is possibly mycorrhizal or a decomposer of organic material. Distribution. Widely distributed in eastern and midwestern North America, with the total range yet to be determined. However, it is rarely found south of Tennessee or the Carolinas. Comments. Many species formerly assigned to the genus Gyromitra have been transferred to the genus Dicena. Some ecologists believe that G. corfi and its western cousin G. montana are better referred to by the European name G. gigas, while others believe that all three fungi are distinct species. The genus Gyromitra dicena is diverse in North America but uncommon in our region. Gyromitra brunei, synonym G. fastigiata, is found in our region but differs in having a less wrinkled brain-like cap that is usually folded on itself. Gyromitra carolina, synonym D. caroliniana, is rare but produces the largest and most striking fruiting body of any similar fungus in our region. The fruiting body has a vibrant reddish-brown, cross-ribbed cap that can be up to 18 centimeters wide, and a white stalk up to 16 centimeters long and 8 centimeters wide. Gyromitra esquilenta is uncommon in our region, but generally has a more prominent and slender stalk, a more brain-like cap, and smaller, smooth spores. Some people eat members of this genus, but this group has been shown to contain toxic and/or carcinogenic compounds and should not be eaten. Helvella latispora, slender helvella, contorted cap-like structure on a slender stalk, 3 to 20 millimeters wide and folded downwards, 5 to 20 millimeters high, saddle-shaped or regularly lobed, upper surface smooth, irregularly undulate, margin usually curving up away from the stalk, pale gray-brown to dull yellowish brown, lower surface smooth to finely pubescent or with fine granules, dingy whitish yellow or pale grayish brown, stalk 6 to 20 millimeters long and 1 to 5 millimeters wide, equal to enlarged toward the base, finely pubescent, white to cream, spores hyaline in mass, 16 to 21 by 10 to 12.5 micrometers, elliptical, smooth. Habitat, biological role. Occurring as solitary fruiting bodies or in small groups on soil or occasionally organic material in many different types of forests, fruiting from spring to summer. The ecology of this fungus is not fully understood. It is possibly mycorrhizal or a decomposer of organic material. Distribution: Found primarily in eastern North America, but widely distributed on the continent. Helvella is a large genus of morel-like fungi. Helvella abdella is morphologically similar, but less common in our region. The upper surface of its cap is generally darker in color, and the spores are larger, 20 to 24 by 12 to 15 micrometers. Helvella elastica is similar, but the margin of the cap usually curves toward the stalk, and the lower surface of the cap and stalk are smooth. Helvella crispa is somewhat similar, but differs in usually being nearly white and having a stalk that is ribbed, chambered, and pitted. Helvella atra and H. pezzozodes are considered distinct species by some mycologists and synonyms by others. Both are dark gray to grayish-black in color and are unlikely to be confused with H. latispora based on color alone, although they do share a similar growth form. None of these species should be consumed. Helvella macropus, the long-stalked gray cup. Cap 1.5 to 4 centimeters wide. At first shallow cup-shaped, but sometimes becoming nearly flat with age. Upper fertile surface, gray-brown to yellow-brown, smooth to slightly wrinkled. Lower sterile surface, gray to gray-brown, densely pubescent, especially near the margin. Stalk 2 to 5 centimeters long and 1 to 5 millimeters wide. Rounded, somewhat enlarged downward. Solid, gray to gray-brown with a whitish base. Spores hyaline, 18 to 25 by 11 to 12 micrometers. Fusiform, smooth to minutely warded, with a large central oil droplet. Non-amyloid. Habitat, biological role. Occurring on the ground or sometimes on decomposing wood in broadleaf or conifer forests. Solitary or scattered and often associated with mosses. Typically fruiting from midsummer through fall. Thought to form mycorrhizal associations with trees, at least under some circumstances. Distribution, widely distributed throughout North America. Comments. Typical specimens of Helvella macropus usually can be recognized by their gray color, shallow cup-shaped cap, and relatively long stalk. This species looks more like a cup fungus than the false morel it is. Helvella cupuliformis is very similar, but often darker in color, and generally has substantially larger asci, 300 to 350 by 17 to 20 micrometers. The asci of H. macropus are generally 175 to 250 by 14 to 18 micrometers. The edibility of both of these fungi is unknown. Morchella americana, the common morel, the yellow morel. Cap honeycomb or sponge-like, held aloft on a cylindrical stalk. Total height 5 to 20 centimeters. Cap 1.5 to 5 by 2.5 to 11 centimeters. Oval, more often elongated. Yellow-brown to tan, with the pits in the cap lighter in color. Stalk 2 to 12 centimeters long and 1.5 to 4 centimeters wide, with distinct ribs or furrows overall and somewhat enlarged at the base. Hollow, white to pale yellow-brown. Spores buff to orange-buff in mass. 17 to 24 by 11 to 15 micrometers. Elliptical, smooth. Habitat, biological role. Occurring on the ground in broadleaf forest as solitary fruiting bodies or in small or large groups, particularly in areas of bottomland near rivers and streams. Fruiting in spring, often listed as a decomposer of litter and humus, but there is evidence that morels can form mycorrhizal associations with trees. Distribution, found throughout North America. Comments. Unlike most of the larger fungi, morels fruit in the spring. Numbers of fruiting bodies vary considerably between regions and from year to year, but in some years they can be abundant. Several similar Morchella species occur in eastern North America, and their taxonomy is challenging and undergoing revisions. Morels are some of the best tasting and easily identified edible mushrooms, but they should never be consumed raw or with alcohol. Morchella angusticeps, the black morel, the eastern black morel. Cap, honeycomb or sponge-like, held aloft on a cylindrical stalk. Total height 7.5 to 15 centimeters. Cap 2 to 3 by 5 to 10 centimeters. Conical to more often elongated. Dark brown to black with the pits in the cap yellow-brown. Pits elongated and longitudinally arranged. Stalk 2.5 to 7.5 centimeters long and 1.5 to 2.5 centimeters wide. Smooth to slightly furrowed. Hollow. White to pale yellow. Spores cream to light buff in mass. 22 to 28 by 11 to 15 micrometers. Long, elliptical, smooth. Habitat, biological role. Occurring as solitary fruiting bodies or in small or large groups on the ground in broadleaf or conifer forests. Fruiting in early spring. Although often listed as decomposers of litter and humus, there is evidence that morels can form mycorrhizal associations with trees. I'm going to apologize because a couple times now I have described something as humus. It is humus. That is a different word. It has only one M in the middle. It is not humus. Humus is not typically found in forests. Distribution. Black morels are found all over the world, but this species is considered to be restricted to eastern North America. Comments. Morchella elata is the name most often applied to the commonly encountered black morel, but this is a complex consisting of many different species. Black morels are often the first morels to appear in the spring. In the Appalachian Mountains, unlike other species of morels, M. augusticeps is more commonly found in the coves higher on mountainside than down in the bottomlands and river valleys. Morchella punctipes is one of the most similar species. However, its honeycomb-like cap is not attached to the stalk. Morels are some of the best tasting and most easily identified edible mushrooms, but they should never be consumed raw or with alcohol. Morchella diminutiva, the white morel, the tulip morel. Elongated structure with an expanded head supported by a stalk of approximately the same length. Total height 2 to 10 centimeters. Head 1.5 to 5 centimeters long and 1 to 3 centimeters broad. Usually conic to pointed, but sometimes curved or blunt-rounded, attached to the stalk, irregularly honeycombed, with vertical or curved ribs and numerous cross ribs. Head grayish when young, but becoming more yellow to whitish with age. Ridges generally paler in color than the pits. Stalk 1.5 to 7 centimeters long and 1.5 to 2 centimeters wide. Equal or enlarged at the base. Smooth, present, or sometimes having fine granules present. White to pale, yellowish tan. Spores 19 to 25 by 11 to 17 micrometers. Elliptical, smooth. Habitat, biological role. Occurring on the ground as solitary fruiting bodies or in groups in broadleaf forests, particularly common in forests located on floodplains or at low elevations under tulip poplars. Fruiting in spring. Our understanding of the ecology of morels is incomplete, and is not known for certain if they are decomposers or form mycorrhizal associations with trees. Distribution. Particularly common in the foothills of the Appalachian Mountains and in the Piedmont and widely distributed in eastern North America. Comments. Several similar pale, yellowish to whitish morels occur in our region, and identifying them can be very challenging, partially because morel taxonomy is only recently beginning to be sorted out, and also because there may be several undescribed species. Morchella septriformis, common at low elevations from Virginia to Mississippi, is now similar in appearance and nearly impossible to separate without molecular data. Small individuals of M. americana are also extremely similar. The good news for those of us interested in hunting morels for food is that all species of yellow morels are tasty. Many were previously lumped together under the name M. deliciosa, and we can leave the finer points of their identities to be determined by more taxonomists, morel taxonomists. Just don't eat them raw or with alcohol. Morchella punctipes, the eastern half-free morel. Elongated structure with a distinct head at the apex of a stalk. Total height 5 to 18 centimeters. The head 1.5 to 4.5 centimeters wide and 1 to 4 centimeters high. Irregularly conic, stalk attached about halfway up the inside of the head. The lower portion of the latter often flaring out from stalk and thus becoming skirt-like. Surface irregularly honeycombed, typically with 15 to 25 major vertical ridges that are longitudinally parallel, sometimes with cross ridges present. Surface between the ridges pale to dark brown, ridges at first brown, but darkening to black with age. Stalk 2 to 15 centimeters long and 1 to 4.5 centimeters wide, irregularly equal or enlarged toward the base, hollow, surface sometimes having irregular longitudinal wrinkles, granular whitish spores, pale orange to yellowish cream in mass, 22 to 28 by 12 to 18 micrometers, broadly elliptical, smooth. Habitat, biological role, occurring on the ground as solitary fruiting bodies, or in small or large groups, in broadleaf forests, fruiting during spring. Our understanding of the ecology of morels is incomplete, and it is not known for certain if they are decomposers or possibly form mycorrhizal associations with trees. Distribution, widely distributed in eastern North America. Comments. The heads of all other Morchella species in our region are attached to the stalk at the margin of the head. Verpa bohemica and V. conica are the most morphologically similar fungi. However, these two species are found primarily in the western and northeastern United States, and whether either one occurs as far south as the northern portion of our region is questionable. In any case, we advise against using either of these species for culinary purposes because they are poisonous to some people. Verpa bohemica has a similar irregularly honeycombed head, but the head is attached only at the apex of the stalk, instead of halfway up the head as in M. punctipes. The stalk is not fully hollow, and the spores are larger. Verpa conica has a smooth head that is attached only at the apex of the stalk. Morchella punctipes is edible, but should never be consumed raw or with alcohol. Many field guides misapply the name of the European half-free morel, M. similibra, to this species. However, molecular studies have shown them to be different. Cup fungi. As their name suggests, this large and diverse group of ascomycetes typically resemble cups, saucers, goblets, or bowls. A few species produce relatively large fruiting bodies, but those of most species are small. Cup fungi are diverse in color and ecological roles. Some are plant pathogens, many are decomposers, and some species form mycorrhizal associations with trees. An amazing feature visible in many of the larger cup fungi is that when weather conditions are right, if you carefully blow into the fruiting body or use a small stick to tickle the inner surface, a cloud of powdery spores will likely shoot into the air. This trick can be a great teaching tool and help a cup fungus disperse its spores. There are a few edible species in this group, but most are too small or poorly understood to be of culinary value, so they are best left for tickling or blowing as a way to mycologically entertain and amaze your friends. Bisporella citrina. Yellow fairy cup. A cup-shaped structure, 1.5 to 3 millimeters across, lower portion narrowing to a small base, surface smooth, bright lemon yellow, spores white, cream, or pale yellow in mass, 9 to 14 by 3 to 5 micrometers, elliptical, smooth, with a prominent oil droplet on each end. Habitat biological role. Occurring in often dense clusters on decorticated logs or stumps, fruiting throughout the summer, decomposer of wood. Distribution. Found throughout North America. Comments. This fungus is often exceedingly common. Although small, the bright yellow color of the fruiting bodies causes them to stand out against the darker substrates upon which they occur. This and related species are too small to be of any culinary interest. Bisporella subpallida is similar, but has shorter spores. Calcina claroflava is similar, but has more narrow spores. Lanza luteovirescens is similar in color, but has long stalks and occurs on small twigs and the petioles of leaves. Bulgaria equinans, also known as rubber buttons or black jelly drops. Can I just say, two of the best names for any fungi that I've encountered in this book so far. Rubber buttons or black jelly drops. Now, shallow cup or saucer-shaped structure with an incurved margin, 10 to 40 centimeters wide. At first, somewhat tuminate before becoming saucer-shaped with age, sessile or attached to the substrate by a short stalk-like base. Rubbery, gelatinous outer surface, dark brown, scurfy, inner fertile surface consisting of a thin brownish-black layer, shiny when wet. Spores very dark brown to almost black in mass, 9 to 17 by 6 to 7 micrometers. Elliptical to somewhat kidney-shaped, smooth, 8 spores occurring in each ascus, 4 of these typically dark brown to black and the others hyalane. Habitat biological role. Occurring in small to large clusters on fallen branches and logs of broadleaf trees, typically fruiting in late summer and fall. Decomposer of wood. Distribution. Widely distributed throughout North America. Comments. Typically, fruitings of Bulgaria equinans are unlikely to be confused with any other fungus, although their rubbery, gelatinous texture is similar to that of some jelly fungi. The overall shape of the fruiting body clearly indicates this species is a cup fungus. Its edibility is not known. Chlorincoila versiformis, the olive brown cup. Shallow, irregularly cup-shaped structure, but becoming more or less flat with age. 1 to 3 centimeters wide. Upper surface olive green to olive brown or orange brown. Lower surface dull reddish brown. Somewhat velvety. Stalk 3 to 6 millimeters long and 1 to 2 millimeters wide. Tapering downward toward the base. Dull reddish brown. Spores hyaline in mass, 9 to 16 by 2 to 4 micrometers. Fusiform to almost cylindrical. Smooth. Habitat or biological role. Occurring as scattered fruiting bodies or in small groups on decorticated logs of broadleaf trees, fruiting during summer and fall. Decomposer of wood. Distribution. Widely distributed throughout eastern North America. Comments. The major distinguishing features of the fruiting bodies of Chlorincoila versiformis are the olive green to orange-brown color of the upper surface and their occurrence on the decorticated wood of broadleaf trees. The specific epithet refers to the somewhat irregular shape of the fruiting bodies. Chlorincoila torta is identical macroscopically, but differs microscopically in having slightly smaller and more elliptical spores. Chlorinspinium chlora is somewhat similar, but differs in being more brightly colored and having smaller fruiting bodies and smaller spores. The edibility of these fungi is unknown. Chlorociboria auregantius, the green stain fungus. Cup-shaped structure, 3 to 13 millimeters across, becoming flattened in age, base narrowing to form a short stalk, bright green to blue-green, upper surface smooth and more vividly colored than lower surface somewhat roughened, spores essentially colorless in mass, 6 to 8 by 1.1 to 2 micrometers, subfusiform to nearly cylindrical, smooth. Habitat biological role, occurring in small clusters on decorticated logs or stumps of broadleaf trees, fruiting throughout the year. Decomposers of wood. Distribution, found throughout North America. Comments. As the common name indicates, the vegetative body, mycelium, of this fungus causes wood to turn green in color. The fruiting bodies are encountered much less often than the green-stained wood. Some woodworkers have found ways to use the naturally dyed wood. However, it is usually too decomposed for them to have sufficient integrity for much other than inlay. Chlorociboria aeruginosa is pretty much identical, except it has larger spores and possibly a more centrally located stalk. These fungi are too small to be of any culinary interest. Dumontinia tuberosa, cup-shaped structure, 1 to 3 centimeters wide, usually becoming flattened with age, arising from a yellowish-brown to black sclerotium, the latter sometimes 2 to 4 centimeters in diameter. Inner surface of cup tan to chestnut brown, outer surface the same color or slightly paler. Smooth. Stalk variable in length, up to 10 centimeters depending on the depth of the below-ground sclerotium. Slender, brown, smooth. Spores white to cream-colored or yellowish in mass, 12 to 17 or 6 to 9 by 6 to 9 micrometers. Elliptical, smooth. Habitat and biological role, occurring on the ground in broadleaf or mixed broadleaf conifer forests, always in association with the rhizomes, underground stems, of various members of the plant genus Anemone, solitary or more commonly occurring in a small cluster. Fruiting in early spring, probably best regarded as a parasite of anemone, but a more complex relationship may exist between the two organisms. Distribution, widely distributed throughout eastern North America and also known from Europe, but found only where the host plants occur. Comments. Its association with members of the genus Anemone, which are common spring wildflowers in eastern North America, suddenly makes this an easy fungus to identify. Because Dumontinia tuberosa fruits so early in the year, the brown color of its fruiting bodies often causes them to blend in with dead leaves on the forest floor. There are other species of brown cup fungi that arise from fruits, roots, or sclerotia in our region. Stromatium repulum is very similar. However, it is not associated with anemones. Monilinia vaccinaceae corimboici is similar, but occurs on the fallen fruits of blueberries. Ciboria carunculoides produces a similar brown cup that contorts the fruits of mulberry. Galliella rufa, the hairy rubber cup. Globose to top-shaped structure when young, but opening to become a shallow cup with incurved edges, 20 to 30 millimeters wide and 5 to 10 millimeters thick, gelatinous texture, tissues clear and jello-like, outer surface blackish-brown, covered with clusters of fine hairs, inner fertile surface tan to pale, orange-brown or reddish-brown, stalk lacking or present, and up to 10 millimeters long. Spores highlighted in mass 17 to 21 by 8 to 10. micrometers, ellipsoid, or occasionally nearly subfusiform, very finely pitted. Habitat biological role. Occurring on the fallen branches and woody debris of broadleaf trees, usually in small groups, fruiting from early spring to late summer. Decomposer of wood. Distribution. Widely distributed throughout eastern North America. Commons. Because of its rather dull color, Galliella rufa often tends to blend in with the leaf litter on the forest floor. Inner tissue is composed of clear jelly-like material, if only visible if cut. No other similar cup fungus produces fruiting bodies with an inner surface that is orange, brown, or reddish brown and has a somewhat gelatinous texture. Also see Bulgaria equinans. Not much is known about the edibility of Galliella rufa. Hey Grace, it's your husband here. Just leaving a little message at the end of this audio where I know you'll never reach it. Anyway, so since I know that you will never reach it, I can comfortably and freely tell you I love you a whole lot. It's nice to have you around, but I'm very glad that you're doing something that is furthering our overall life plans and also making you happy and is a cool opportunity. And I'm really happy that it's going well for you. I know I said this already, I really do love you to pieces. I'm really glad that we're talking as much as we are. Hope that you're having a great time. Anyway, if you ever do happen to hear this, then tell me the code XV59Y. You can tell it to me or text it to me. And if you give me that code, you'll get a free chicken junior. Yep. Anyway, have a good night.